Welcome back. This lesson is about series resistance, voltage drop, and what's so great about a voltmeter compared to using an ohm meter or an ammeter to troubleshoot electrical systems. Remember from previous lessons that the electrical properties of resistance, ohms, impedes or restricts the flow of electricity, amps. Our cast of characters today is a battery, a switch, and a load. Even a fully charged battery has a minuscule amount of internal resistance to the flow of electricity, although this amount is so tiny that it doesn't affect the other electrical properties. Until the battery dies. Then the internal resistance rises dramatically as the battery has exhausted all its stored static energy. In this circuit, we use a switch as a control device to turn the load on and off by opening and closing the switch. When the switch is in the open position, it has infinitely high resistance, and we call that an open circuit because the pathway for the electrons to flow, amps, is incomplete. 0 amps flow through the circuit. Once we close the switch, however, the switch becomes more like a wire, and the minuscule, insignificant amount of internal resistance in the switch does not impede the flow of electricity. Using Ohm's law to calculate the circuit current, we simply divide the 120 volts by 40 ohms for 3 amps of circuit current. But as the switch gets old and wears out from use, that tiny minuscule internal resistance starts to grow until it becomes significant enough to impede or restrict the flow of electricity, amps. Let's say we test the switch with an ohm meter and we discover that the switch has 4 ohms of internal resistance. Adding the switch resistance to the load resistance and using Ohm's law, we can then calculate the impact of the added resistance. We already know that the ideal circuit current is 3 amps from the last slide. But now with the extra 4 ohms in the switch, our circuit current is 2.72 amps. So the resistance in the switch impeded or reduced the circuit current by 0.28 amps, or almost 10%. A load is any device or appliance that runs on electricity, a hairdryer, power tools, computers, etc. A load has internal resistance too, and the amount of internal resistance that a load has an inverse relationship with the amount of circuit current, amps. Remember from Ohm's law that if a circuit resistance goes up, the circuit current must go down. Okay, so what's so special about a voltmeter and knowing how to use one? If you suspect you have a defective switch and want to test it with an ohm meter, what do I have to do? Well, first I have to remove the switch from the circuit, and then I can test it with an ohm meter. What if I want to check it with an ammeter? An ammeter measures amps. In this case, I still have to remove the switch and install the ammeter in series with the circuit. But if you know Ohm's law and you know how to use a voltmeter, you can look for what's called voltage drop. Unexpected resistance in a series circuit, according to Ohm's law, must result in a voltage drop across that unexpected resistance. And if you can find it with a voltmeter, without having to disconnect anything or take anything apart, all the better, right? In this example, first I put my voltmeter across the load, and I discover that I have 109.1 volts. Next I go to my power supply and check my power supply voltage, and sure enough, 120 volts, as it should be. So it seems I'm missing 10.88 volts somewhere, and I wonder where it is. I measure voltage drop across the switch, and sure enough, 10.88 volts. Ohm's law wins again. Let's say our control switch is unexpectedly turned off. Again, you can find it with a voltmeter without having to disconnect anything or take anything apart. I start at the load and I see 0 volts. I check my power supply again and full power. I go to the switch and find it in the off position. Gotta love a simple fix. But seriously, if I did put my voltmeter across the switch while it was turned off, I'd see the full battery voltage on my voltmeter. This is what the voltage drop across the circuit would look like if we had a broken ground wire. And finally, the ideal scenario looks like this. You see the full supply voltage across the load with your voltmeter. If you ever see anything less than, say, 95% of full supply voltage across your load, you can be suspicious of unexpected resistances causing unexpected voltage drops. So grab your virtual voltmeter and see if you can find them on this next quiz.